Okay, so here all the variables such as investment, GDP and education rate are found co-integrated, so we can run the VECM model, and that we shall do now. I go to quick estimate var, then I choose VECM. Okay, then this time I put GDP first, right? Then I put investment, then I put education rate. Education rate. Education. So, so this is the variable I am setting. Actually, what is our hypothesis? The hypothesis is our variable that is called in investment. Investment causes GDP and GDP causes education rate. So that is our hypothesis. So that is why I put GDP first. I put GDP first to check whether our variable, which is in investment, can cause GDP or not. So that is why I put the GDP first to check whether investment can cause GDP or not. I'm telling again, what is our hypothesis? Yeah, our hypothesis, in the short run, investment causes GDP and GDP causes education rate. So that is the channel. So that is why I put the GDP first. Okay. And here the lag is 2 lag. And here, and I have chosen the var VECM. And here I go to co-integration. Yes, here is already 1 because because uh, from the Johansen test from the Johansen test we got one co-integrated equation. So here I put one co-integrated equation because uh, Johansen test is telling Johnson test is telling to take only one co-integrated equation, and that is why I put here 1 and 3. Okay, I keep it like this. I keep it like this. 3. I choose number 3, and so other things are remain unchanged. And here and we can run the model now. Okay, and you see this is my vector error correction model. This is the outcome, right? This is the outcome of the vector error correction model. Oh, sorry, I'm taking it back again. Where is it? Where is the outcome? Yes, this one. This is the outcome of vector error correction model. You can see from here, and this one is the co-integrated equation, and GDP is the dependent variable. And here you can see the 3 error correction model. this is the dependent variable, this is the dependent variable, and this is another dependent variable. And you see, last time we put only GDP, but but the GDP has converted to first difference. Actually, VECM always convert the variables into first difference. She always does it. Whether you want or do not want, she will convert the variable into first difference all the time. So that is why last time I just put GDP, but this GDP has converted into DGDP. Last time I put investment. This investment has converted to de-investment. That means first difference. Last time I put education, but this education has converted to de-education. So that always VECM does normally. And here you see we have chosen 2 lag. So this is the outcome, lag 1, lag 2, lag 1, lag 2. And here suppose this one, it is the coefficient, it is the standard error, and it is the t value. So this divided by this, you can get this t value. I am saying again, this is coefficient, this is standard error. This divided by this, you can get the t value. But the problem is that here is no p value. Here is no p value, but we want to see the p value, right? So that means for these 3 variables, for these 3 models, we want to see the p value. How to get the p value? So actually we have to go to system equation to see the p value of each variable. And here this is dependent variable and these are all independent variables. This is dependent variable and these are all independent variable. And this one is the what? Error correction term. Error correction term, error correction term. And here we have only one error correction term. Okay, now we want to see the p value. So how to see the p value? I go to proc, I go to make system, then I go to order by variable. So now you can see our 3 model. This is model number 1, DGDP, dependent variable, and D investment, that is another dependent variable, and D education is another dependent variable. So out of 3, we shall choose only this one. We shall choose only this one. And yeah, here this one is the co-integrated equations from here to here, right? This one is the co-integrated equation, and from there we shall take the residual, and that residual actually is error correction term. The residual from this co-integrated equation would be error correction term. 1 period lag of the residual of the co-integrated equation. 1 period lag of the residual taken from the co-integrated equation. So this one is our co-integrated equations. Okay. So, and this one is the coefficient, and this software will automatically estimate the error correction term. That they will do it. So actually this software will extract the residual from here, right? From here. From here means co-integrated equation, and this residual will be error correction term. So what I do, I only choose this one, right? Not other model, only this one. I copy this one, I copy, and I go to quick, then estimate equation, then I paste our OLS model. It becomes now OLS, or error correction model. One way error correction model. You can see the model. Here the GDP is the dependent variables. Okay, then press OK. Okay, this is our estimation. You can see from here, and the dependent variable is GDP, and others are independent variables that we can see from here. And from here you can see one thing. It is our model, right? It is our model that you can see, and here C1 is the error correction term, the coefficient of the error correction term, which is C1, this one, right? Okay. And what about C8? C8 is the this one. What is C8? C8 is the intercept of this model. So so here is few things. Number one is C1, which is error correction term. It is negative and also significant, because the p-value is less than 5%, and it is also negative. So error correction term is negative and significant, meaning that it uh, uh, meaning that this suggests the validity of the long run associationship among variables when the error correction term is significant and negative. Okay. And now we talk about short run causality. Short run causality. Okay, whether our variable such as in investment can cause GDP or not. That we want to check first, right? Why? Because our hypothesis is the variable such as is the variable such as in investment. The variable investment causes GDP, and GDP causes education rate. Okay, first I check whether investment can causes GDP or not. And here you can see the investment has lag 1 and lag 2, and it is C4 and C5, right? Okay, so then how to check? Go to view, then coefficient diagnostic, wall test. Here I shall be using the wall test to check the short run causality, not long run, short run causality, or the channel, transmission channel. Okay, then I shall be writing here C4 equal to C5, right? Equal to 0. Jointly they are 0. That is the null hypothesis. And if they are 0, meaning that investment uh, does not cause GDP. Okay, so that is our null hypothesis, that investment does not cause GDP. I okay? You see the wall test, and it is the null hypothesis, and chi square value, and corresponding p value. How much is the p value? Less than 5%. So we can reject null hypothesis. It is the null, meaning that C4 and C5 is not jointly 0, meaning that in our variable is which one? In investment. Investment can cause GDP because the null hypothesis is not 0, because C4 and C5 is not 0. Okay, so that is our one result, that investment causes GDP. Okay, then we check one more thing, where it has gone from the model. Why the thing is that? Has it gone somewhere? Okay, sorry. And now we can check that. I'm sorry, it has lost. Okay. Now we can see again whether coming back. Sorry. We can check again something. Just 1 minute. Okay, here we can check some more things such as, okay, so this is our model, right? We can check some more. I'm sorry. And I'm sorry, it is losing. Okay, just come back. Okay. Okay. And okay, so and here we can reject null hypothesis that we have seen. Okay, now we check some more things such as what is our model. So this is our model, right? And so the investment causes GDP, that is understood. Now we check whether the education can causes GDP. in the short run. We can also check this one. How to check? Actually here we shall be doing the same thing, that is world statistics, and here C6 is the coefficient and C7 is the coefficient. So I go to world statistics as before, and I put C6 equal to C7 equal to 0. So that is the null hypothesis, C6, C7, 0. And if they are 0, meaning that education cannot cause GDP. So now we can check it. Okay, world test, and it is the null hypothesis, C6, C7, 0. These are the coefficient of education. So chi-square p-value is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that C6 and C7 is 0, meaning that our education rate cannot influence GDP, cannot cause. That means there is no causal channel, there is no causal effect from uh, education to GDP. Okay, so what is the outcome of this model? The outcome of this model that uh, education cannot cause GDP, but our another variable which is called which is what in investment, which is investment, that can cause GDP. So I'm telling again, our education rate cannot cause GDP, but our investment can cause GDP in the short run. So that is the outcome. Now we shall be checking how is the model. That means we shall be doing now diagnostic checking. How is the model? That means whether the model has a problem or not. So that we shall check now.